Welcome to Brain Vision.
So here in this problem we are given that the steel rod and aluminum rod have same diameter and are placed end to end between the rigid support as you can see in this figure, and we are given that the length of steel rod is 0.450 meter and the length of aluminum rod we are given as 0.250 meter, and initially there is no stresses in the rod. Now we are given that the temperature is raised by 60 degrees Celsius. So delta T we are given as 60 degrees Celsius. Now we have to calculate the stresses in each rod. Now we know that the total length, that is this total length delta L, would be equals to 0. But if we take the delta L for individual rod, that is delta L for steel and delta L for aluminum, it will change. And the expression for change in length delta L with respect to temperature, we are given by the expression L naught, where L naught is the initial length, times alpha delta T. Alpha here is the coefficient of thermal expansion, plus F over A times the Young's modulus. F over A is the stress here. Now we can write the formula respectively for aluminum and the steel. So if we write delta L for steel, it will be equals to initial length of steel, that is LST, times alpha for steel times delta T plus F over A times the Young's modulus of steel. Similarly, delta L for aluminium would be equals to L for aluminium times alpha of aluminium times delta T. Here F A and delta T is same because delta T we are already given, that is 60 degrees Celsius, so it is same for both the cases, and F and A will also be same because the diameters are same. So the force induced in between these two materials would also be same. So F over A times the Young's modulus of aluminium. Now we'll be writing the properties for the two different materials, that is alpha of ST, coefficient of thermal expansion for steel, we have 1.2 times 10 to the power minus 5 per degree Celsius. Similarly, alpha for aluminium, we have 2.4 times 10 to the power minus 5 per degree Celsius. Now next, the Young's modulus for steel, we have 20 times 10 to the power 10 Pascal, and the Young's modulus for aluminium we have 7 times 10 to the power 10 Pascal. Now we know that the total length delta L of aluminium plus the steel plus aluminium will be 0. So we can plug these value here. So delta L is for steel, we have L times steel times alpha ST times delta T plus F over A, Young's modulus of steel, plus length of aluminium times alpha for aluminium times delta T plus F over A times the Young's modulus of aluminium will be equals to 0. Now from here we're going to evaluate the expression F over A. Now from here the expression F over A, which is equals to sigma, will get us minus alpha of steel times the length of steel plus alpha for aluminium times the length for aluminium divided by the length of steel divided by the Young's modulus of steel plus the length of aluminium divided by the Young's modulus of aluminium times delta T. Now we have all the values, we can plug it here to calculate the sigma, stress induced in both the material. So it will be minus 1.2 times 10 to the power minus 5 per degree Celsius. And length for steel we have 0.450 meter, plus alpha for aluminium we have 2.4 times 10 to the power minus 5 per degree Celsius, times the length we have 0.250 meter, and delta T we have 60 degrees Celsius. So this much, and divide by the length for steel we have 0.450 meter, divide by the Young's modulus for steel is 20 times 10 to the power 6 Pascal, plus the length for aluminium we have 0.250 meter, divide by 7 times 10 to the power 10 Pascal. So this is what we have got. Now we want to solve it with our calculator, and we'll get the value for stress equals to minus 1.2 times 10 to the power 8 Pascal. Now here negative sign represents that the stresses are compressive in nature. So I hope you have understood the problem. Thank you.